Okay, Coroneos 100 integrals number 30. This question is really similar to the one we just did before. It was question number 29. For question 29, this number here was 5 and the number here was 3. So they just simply switch these two numbers around. All right, how do we do this question? It's going to be T-form and substitution again. But towards the end, you will see that it's going to be using a slightly different method to do a final integration. So that question is a bit tough. Let's do the T-form of substitution. We're going to let T equals to tangent x on 2. And we're going to create a right angle triangle for the later uses. So we've got x on 2 here. That's T, that's 1, that's a square root of T squared plus 1. Now we need to differentiate both sides. So we end up with dt equals to sec the square x on 2 half dx. If we move everything here to the left-hand side, we end up with 2 cosine square x on 2 dt is equal to dx. Alright, so once we finish that, we need to actually use the triangle we had previously. Alright, cosine x on 2 is adjacent over hypotenuse, which means that's just equal to 1 over the square root of t squared plus 1. How are you going to square it? That's dt equals to dx. So at the end, we get 2 over t squared plus 1 dt is equal to dx. Alright, so that's what dx equals to. So I'm just going to highlight this part. And that's what we need to substitute this one back inside. Alright, so once we have this information, the next information is cosine x, according to the t formula, alright, it is equal to 1 minus t squared over 1 plus t squared. So that's the second substitution we need, the cosine x. Alright, so let's start the process by substituting everything we have inside. Okay, so we're going to integrate. The dx is equal to 2, so we're going to just do 1 over, we multiply by 2 over t squared plus 1 dt. Alright, so for the denominator, you get 3 plus 5 multiplied by everything, 1 minus t squared over 1 plus t squared. Alright, so if we multiply numerators together, that's 1, that's 2, you end up with 2. Okay, over, it's going to be a long fraction. And then what we are going to do here is we need to multiply the 3 with the t squared plus 1. So we get 3t squared plus 3 plus, now we need to multiply this by this term. Hopefully you realize that again, the denominator cancels with the terms here. So therefore we end up with 5 bracket 1 minus t squared dt. Alright, so that's the next line of working out. So next we need to expand the bracket and we need to simplify it. So we've got 3t squared plus 3 plus 5 minus 5t squared dt. Okay, alright, so the next we need to combine the like terms on the denominator. So we get 8 minus 2t squared dt. Okay, I hope you still remember from the previous question that it was maybe 8 plus instead of 8 minus. Alright, so this time we get a minus. Alright, so inverse trig integration is not going to help you to do this question here. So after we're simplifying it, we get 1 over 4 minus t squared dt. Okay, so how do we do this question from here? If you just pay attention to the denominator, that looks like very similar to the difference of 2 square that we can use. But how does that help us to do the question? So from here, we need to decompose these integrams into partial fractions. All right, so we're going to let 1 over 4 minus t squared equals to a over, now we need to apply the difference of 2 squares, 2 plus t, so 4a over 2 plus t plus b over 2 minus t. Okay, now we need to combine the fractions on the right hand side. We get a bracket 2 minus t plus b bracket 2 plus t oops, I've got 2 t and t. 2 plus t is equal to 1. So we're going to let t equals to 2. That gives me 4b is equal to 1. B is equal to a quarter. And if we let t equals to minus 2, we get 4a equals to 1. A is equal to minus a quarter. So yes, this question requires you to use the t form in substitution. And once you finish that, you still need to use a partial fraction to solve it. All right, now we can continue. So we've got a and b. We can substitute back into here. We should get a is here and b is there. So that gives us minus 1/4 over 2 plus t plus a quarter over 2 plus t dt. Right, so this is just going to be the logarithm, sort of like integration, that you're integrating reciprocal function. So the first one is going to be negative 1/4 ln absolute value t 2 plus t. Right, plus and t looks very similar. 2 plus t plus a quarter ln absolute value 2. Should be minus t here. That should be a minus t. Minus t. All right, and plus c. What you can also do is by combining these two log together. So that gives you 1/4 ln absolute value 2 minus t over 2 plus t plus c. Okay. Is that all? No. We still need to replace the t. Okay, so we know that t is equal to tangent x on 2. So for this one, it's pretty easy. All we have to do is direct substitution for the things we have here. So we've got t equals to this, and we're going to substitute into t here and t there. So that gives us 1/4 ln absolute value 2 minus tangent x on 2 over 2 plus tangent x on 2. Absolute value plus c. Whew, that's how you solve this question here. It's a really good question. I really like it. But this question is really long, and you need to pick the right method to use. So it's going to start with t formula substitution here first to replace this cosine x in terms of t. Once you finish that, if your algebra is correct, you end up with something like this, or something like this one here. Then you need to realize I'm going to use partial fractions, so we're going to separate that into two fractions. And then you need to find out the value of a and b before you can, integrate it. Okay, it's a really good question. Thanks for watching.